Okay. So, Arjun. So in yesterday's class, we were discussing the mm, I think yes, here's A2 physics and right here. Okay. So the previous chapter was about the simple harmonic motion. Okay. We did the concept of we did everything in this chapter. And now we have to try the electric field. Okay. So let's start with that. Okay. So we have electric field and potential. Okay. Just give me a second. Wait. Come on. Okay. Let me just do a quick heading. Electric field, electric field. Okay. And potential. Potential. Okay. So this is going to be the new chapter we are discussing, or we will be discussing. Okay. And in this chapter, uh, the question pattern are going to be quite difficult. But it is like similar to what we've learned in the gravitation, right? Like the formulas and everything are quite simple or like quite related with the previous chapter of gravitation, but the concepts are going to be shit. Sorry. Mm, just a second, please. Trash. Yes. Okay. So, but the concept is going to be quite difficult because we are going to have the charges. Okay, in this chapter. Okay. So let's start with that. Um, so I have the first thing to start this chapter off is the concept of the electric field. Okay. I'm going to follow the exact same pattern as of the gravitation. Okay. So electric field. Okay. So first to discuss the electric field. Okay. And then we'll be discussing electric field strength. Okay. This is the first thing. The second thing is going to be the electric field strength. Okay. Field strength. Okay. Just a second. Now, so electric field, the definition for the electric field is basically it is a region of space. Oops. Okay, so it is the region of space where the electric charge, where the unit positive test charge experiences an electric force. Electric force. Okay. So this is the concept of the electric field, right? Now, in this definition, we have um, oops. Right. Mhm. But not this. Okay. So in this portion or in this definition, we have discussed three things. The first thing is the region, okay, and the second thing is the electric force, okay, and the third thing is unit positive test charge, okay. So these are the three things that we have to discuss in this portion, okay. Now let's first talk about the electric field strength, and then we'll move on to the other things, okay. So electric field strength is going to be the force per unit charge, okay. It is the electric force per unit charge, okay. We can say that it is the electric force per unit charge, okay, per unit or rather you can say per unit positive charge, not just a charge, okay. The word positive is a key word, you have to write it, okay, don't miss it. Now, so this is the second concept, okay. So this is the concept of the electric field strength, okay. And if you just look at the equation formula, sorry, definition, so you can form the equation, okay. So electric field strength E is equals to electric force EF divided by the charge, okay. And this is the concept, by the way. Oops. Um, okay. So this is the concept, right? So this is the electric field strength. So this is the formula for the electric field strength, right? So by the way, can you guys tell me the unit for it, please? The unit. Anybody? Yes. Anyone?
Newton,
Newton only?
Newton per unit coulomb,
Very good.
numbers.
Um, Newton per coulomb. Okay, very good. Fine. And this is, by the way, the vector quantity. Vector quantity, right? So we have to keep in mind the direction while discussing the electric field strength. Okay. Now, so so we first have to discuss the electric field, electric force, and then charge, and then we'll be able to understand the concept of the electric field. Okay. So in this chapter, whenever we talk about the charges, okay, so they're going to be charges. So charges are basically the fundamental characteristic of a body, right? And we'll be considering two type of the charges. One is going to be um, the one is going to be the test charge, and the other is going to be the source charge. Okay. So the first one is going to be the test charge. The second one is going to be the source charge. Okay. So we have the test charge, and the source charge. Okay. So test charge is basically the unit positive charge. Okay. That experiences the electric field. Okay. So it is a unit positive charge that experiences the electric field friend of the source charge. Okay. Now, so this is the concept of the test charge, right? Now, it will always going to be a very small in value, right? Like a proton, okay? Like the alpha particle, okay? So these are going to be, or these can be considered as the unit positive test charge, right? So, but the test charge should be like this, okay? And we have the source charge, and the source charge is basically the one that generates the electric field around it, so that it can be experienced, like the planet that generates a gravitational field around it, or that creates a gravitational field around it, so that we, the humans, or the man-made things, can be experience, or can be able to experience or study that thing, right? So everything experiences the gravitational force. We can study the gravitational force along with the experiencing the effect. Okay, so we can say that the source charge is basically charge that uh, creates magnetic field around it. Okay. So, and they look like this. Come on, stop. Shit. Why it is lagging? I just want these two things. Sorry. Okay. So the source charge is like this. Okay, these are the source charges. It can be positive, it can be negative, it will be of a very large magnitude. Okay, these are some of the possible qualities of the source charges. Okay, they create a magnetic field around themselves, right? But but the test charge is going to be only this charge, okay? And it will be of a very small in magnitude, like that. Okay, this is going to be the test charge that experiences the source charge. Okay, now, so this is the concept of the charge, by the way, right? You know that the smallest value of the charge is going to be um, the smallest measurable um, charge value is 1.602 exponent negative 19 coulombs. Okay, also known as elementary charge. elementary charge value. Okay, this is the smallest ever possible charge that can be recorded on any object, right? So yes. Now, so if you talk about this is the first thing, by the way, okay, the concept of the charge. Okay, now we have to discuss the concept of the region first, and then like how the charges can create the electric field region around themselves, and then we're going to move on to the electric field. Okay, but by the way, please keep in mind the electric field are one of the two types. Okay, so electric field, the first electric field is basically the non-uniform electric field. Okay, and the second thing is going to be the uniform electric field. Okay, so previously the uniform electric field was um come on. The previously the uniform electric field was a part of the AS level physics, and it was then shifted to into A levels in 2022. Okay, so it is just recently added chapter or portion. Okay, so these are the two type of the electric field that we have. Okay, right. So we first discuss the concept of the charges. Okay, and this charge is the type of the charges, the source charge and the test charge, and we also discussed the concept of the type of the electric field strength or electric field region. Now we have to discuss how the region, electric field region looks like. Okay, so this is, by the way, the type of the electric field. Okay, so this is the type of the electric field. Okay, over here, type, type of, type of electric field. Okay, and then we have. So this is the type of the electric field, and we have two types, by the way. Okay, and now we have the region of the electric field. Okay, so we're first discussing the non-uniform electric field. Okay, so non-uniform field. Okay, not come on. Okay, so I have non-uniform field. Okay, okay. So this is something that we have to discuss the non-uniform field. Okay. And in the non-uniform field, we have to discuss the concept of the like charges and unlike charges and the separate charges. Okay, so these are the three things will have to discuss. Okay, basically the field pattern. Okay, because sometimes they ask you to draw the field line, or you have to figure out yourself. Okay, so I have, it's a very simple thing. You should know it. Okay, I'm just copying and pasting the thing. So I have right here the things that I've drawn. Okay, copy and paste. Now, so basically, the first one, the first one is where you have the individual charges, okay, and the individual charges creating the magnetic field around themselves. Okay, so for the negative charge, and for the positive charge, the field lines are basically radial, okay, the way it was in the gravitation chapter. But the direction of the field line points inward for the first negative charge and outward for the positive charge, right? So this is the first scenario, by the way, right, where both the charges or both the spheres acting as a two separate charges, they are situated in the separate space. Okay, Like they don't have any interaction between them, or they're not at a distance at such distance where they can interact. Okay, so they're like far from each other. They are the two different scenarios, right? But if we put the two charges together, so if they are of the same charges, then it looks like the last one. Okay, and it is, by the way, not any sort of spider or something, but maybe it looks like so from the front, right? Like these are the red eyes. Okay, these are the red eyes, and there's something like a mouth. Okay, and these are like little some sort of things. But they are the charges. Okay, so so this is how the electric field interact when the same charges appear to be next to each other. Okay, but when the charges are of the different types, okay, they start attracting each other. Okay, so this is how the electric field look like. Okay, so electric field start from a positive charge, and it entered into the negative charge, and this is something that you have to be careful. Okay, and you know that the distance or the separation between the field line shows the strength of the field, right? So as it get increased or larger, so the strength of the field become weaker, right? Now, okay, let me just where is this one? And I have that one. Okay, so this is, by the way, the concept, the simple concept of the electric field reading, right? And you also know that their properties or their come on. So now we have the properties or properties of the field. Okay, so two prominent properties that you should keep in mind every time while doing this question. The first one is field follows the inverse square law. Okay, so this is the first thing. Okay, like the field line and the field value and everything basically shows you that you're basically taking the field value and not anything else, right? So this is the first thing, right? And the
Sir,
second thing, yes,
uh, field follows the inverse square law.
it follows.
Okay, you wrote flows.
Yeah, my bad. Field follows the inverse square law. Okay. As well as the gravitational field and this electric field. Okay. This is a similarity, by the way. Okay. This is the second is basically the field lines will always be radial in nature. Okay. This is the second concept. Okay. Then the field line will always be radial in nature, right? These are the two similarities between the gravitational field and the electric field lines. Okay. Now the difference is, they most of the time they ask you to write the difference between the gravitational and electric field, or gravitational and magnetic field, or electric and magnetic field, right? So these are the 2 points. The third point is going to be The third point is going to be field can be inward, not inward, inward or outward. Depending upon depending. Okay, so field can be inward or outward depending upon the sign of the charm. Okay, so this is the third concept, and this one is the point where the electric field differs with the gravitational field. Okay, because gravitational field can only attract the object, while the electric field can also attract and repel the object, right? Like if you have a positive charge and a positive charge, so both are going to repel, right? But if you have the opposite charges, then both are going to attract, right? So this is the concept, and the rest of the field lines can be found in the gravitation chapter. You can consider, like you can take a look in this and that chapter, right, where we wrote some sort of the field strength and the distance relationship. Okay, the time and the frequency relationship, and yes, some more. So basically, there were some properties that were that we discussed in gravitation, but these are some properties that are specific with the gravitational force, right? Now, if we try to find, okay, by the way, we have three things to understand, right? The first thing was the region of space where the electric field generating itself, right? The first thing. The second thing is where the unit positive stress charge experiences. Okay, so where it experiences the source charge field, right? Because if it is that much small, so obviously you may not be able to give him or put him some more thing to work with, right? Or to measure, right? So it will give you most of the time the imbalances in reading or fluctuation in reading, but you can rather um, okay, so you can rather look at how the electric field value goes, right? So now the properties are done, okay, and the field, the region is also done, the test charge is also done. Now we have the electric force, okay. So to understand the concept of the electric force, we have to discuss the Coulomb's law. Anybody, by the way, remember the Coulomb's law?
No.
Yes. Nobody? Coulomb law.
Is it
Um, yes.
is it uh current current into times? I don't know. I'm not sure.
Okay. So it is basically Coulomb's Coulomb's law. So this is basically something that we have discussed, okay, in gravitation chapter, right? Come on. Oh, okay. The whole thing, okay. So in Coulomb's law, if you keep the two charges, so you yes, oops, wait,
Sir, Is there like a book with all of the notes?
Sorry, is like
Is there like a book with like all of the notes?
uh actually no, because I'm just making it with my brain, okay, on the spot. But yes, I can provide you with the note after the end of the chapter, rather, if you
Yeah,
want.
okay. Yeah.
Okay. So Coulomb's law is basically if you have the charge, let's say if you have this charge, okay, if you have this charge, okay, and you have another charge because this is a source charge, right? And that this generates the electric field around itself, okay, and you have the source charge very small, and like it is right here, and it is to experience the nature of the field generated by this charge, okay, and this one is going to experience how the magnitude varies, okay, as it moves from one point to another point, right? So I have these distances. The first one is from the center to the center of the sphere of the two charges, okay? And the second one is going to be the magnitude of the charges, right? So we basically change if we change anything, right? So the force will increase itself, right? So if we have electric force, okay, electric force, if you increase the value of any charge, the repulsion between the charges increases, right? So they are directly proportional to the product of the two charges, okay? And electric force is basically inversely proportional with the separation, okay? Inversely proportional with the separation. So if you want to combine these two formulas, so it look like this. It is basically squared in relationship. Okay, so Fe is equals to KQ over R. Okay, now so this is the concept of the sorry. Wait. Just give me a second, please. It should not look like this. If we combine these two formula from the above, so it will be Q1 Q2 over R squared, right? And then if we so if we try to remove the proportionality with equality, so F is equals to K Q over R squared, right? This is the formula, okay? And over here, the K has a value of 8.99 exponent negative 9. Negative, sorry, exponent 9, not negative. Okay? And if you try to write down its units, so Newton meter square per kg, right? Per kg square. Okay? So this is the value of the charge, okay, and it is basically like K is basically the medium value that allow the two charges to interact, okay. So if this value increases to a higher point, then you may see the charge sparking with each other, right? So that's why we keep this thing very small in value, right? And using that, we got the value of K and the two value of Q's and their separation R, right? Now, mm, by the way, you can also find out their space quantity, okay, but for now, this works. But so this is the formula. Sometimes they relate K. K is, by the way, is a constant. Okay, K is a constant. Fine. By the way, time was okay. Yes. So K is basically equivalent to 1 over 4 pi epsilon naught. Okay. So the K is related to some other factor, and that is called epsilon. And this factor is basically directly related with the object or with the raw material that you have, right? Or this is a place where the things get like molded or um so this E naught is basically help you in finding how the two charges can easily interact if you place them in that medium, right? But by the way, this is we just consider the medium or the free space value, right? We only consider the free space value. Come on, we not. This is the there's something we call permittivity, permittivity of the free space. Okay, free space, and it does not allow the two charges to interact because it has a value of 8.85 exponent negative 12. Okay, they gave you this value in the paper, right? So by the way, this is the concept of the Coulomb law. Okay, now I'm ending the class right here because there's an advanced time. Okay, I'll continue tomorrow. We have 2 to 3 things left, so I'll probably end the chapter by tomorrow. I'll try my best to end the chapter by tomorrow. Okay, or basically the topic by tomorrow, and then I have one more thing. If we can complete it on Wednesday, then we perfect. Okay, not Wednesday, Thursday, Saturday. So it would be like then I'll be giving you the homework for the whole chapter. Okay, but for now, that's it for today. Okay, and in the next class we'll do some of the remaining things. Okay, fine.
So,
Okay, take care, guys. God bless.
sir,
Yes.
I wanted to ask something about the last part, the E naught value. Will it be given in the marking in the MF in the